So this is a video on complex numbers. Complex numbers are numbers that are expressed in the form a plus bi, with I being a theoretical number that satisfies the following equations, such as I squared equals -1, I to the third power equals -I to the fourth equaling +1, and so on with that pattern. So, complex numbers, they're often used to express the square root of negative numbers. So, if the square root of 25 is +5, then the square root of -25 would be 5i. So let's do a problem. So, in this problem we have, I'm going to kneel down, okay, 3 plus 5i times the quantity 3 minus 5i, with your a value being 3 here, your b value being 5, and yeah, same pattern. So you would start by foiling this like a regular binomial. So 3 times 3 equals 9. 3 times -5i is -15i. 5i times 3 is 15i. And 5i times -5i is -25i squared. So these two would cancel, these two would cancel out because it would be -15i plus 15i, so that would equal 0. And when you have I squared, it always equals -1, so if you have -25 times 5i, -25 times -1, it would equal +25, so then you can add together 9 and 25 and you get 34, so that's your solution. Alright, so we're going to do one more problem that's a little more complicated, and you would start off again by foiling these. It's 8 plus 9i times the quantity 7 minus 3i. And so by foiling them, you do 8 times 7, which is equal to 56, and then you would do 8 times -3i, which equals -24i. Then you would do 9i times 7, which is 63i, and you do 9i times -3i, which is -27i squared. So then you would add these two together because they have like terms, and that would you would get positive 39i, so you would have 56 plus 39i plus -27 times -1, because remember I squared equals -1. So once again you would get, 56 plus 39i plus 27, because -27 times -1 is positive 27. So then these two are like terms, so you can add them together, and you get 83 plus 39i. Boom. All right.
Okay.
Oh.
Yep.
Okay.
All right. Now we're going to do some problems with complex numbers in fractions. So when complex numbers are in fractions, they're normally in the form a plus bi over a plus bi. To simplify these equations, you have to find the complex conjugate of the denominator, meaning a plus bi becomes a minus bi, and then you multiply both the numerator and the denominator by this complex conjugate. So a plus bi times a minus bi, and the same thing on the bottom for this one. So we're going to try some problems with complex conjugate fraction solving. Here we have 3 minus 5i over I, which is an easier problem because we don't have the full a plus bi on the bottom, so the complex conjugate is only -i. So you're going to multiply both the numerator and the denominator by -i. So then you get -3 times -i equals -3i, and -5i times -i is positive 5i squared over 1, because that's what this is, and anything divided by 1 is the same, so you have this, and as we know from before, I squared is -1, so we have -3i minus 5 as our final answer right here. Now we're going to try a problem with a little bit with the full a plus bi format on both top and bottom. So the complex conjugate is 1 plus 2i, so we're going to multiply the numerator and the denominator by this complex conjugate. On the top we're going to get 7 plus 14i minus 4i minus 8i squared over 1, because these multiplied together equals 1. So combining these like terms, 14i minus 4i is 10i, 7 comes down, and we know from before that I squared is negative 1, so 8 minus negative times negative 1 equals 8. And then we get 15 plus 10i, and there's a common factor of 5 here, so we can just take this, divide it by 5, and get 3 minus 2i as our final answer. Thank you for watching.